Hello everyone, my name is Shaunak and you're watching this video on my channel Physics for Students, and today I would like to talk a little bit about real analysis and how you can learn real analysis easily. Find this something as a very difficult subject. Now you see that what happens is that in real analysis is the first proof-based mathematical system which a student or a candidate encounters during his or her journey into mathematics. The first proof becomes a kind of a problem. You really feel frustrated because you cannot understand anything. It is a very dry, raw subject which has no interest for you. And this is where you are wrong. I mean to say, this is the problem with real analysis. So the objective of today's video is not to teach you the mathematics of real analysis, but I would say to give you a kind of an insight which you probably don't know, that what is the power of real analysis and how this real analysis can be so much interesting in your future career. Now, to be very honest with you, I will make the video in such a way so that you really understand the idea behind it. I'm not going to teach mathematics. First of all, you need to understand that real analysis is actually taught, I'm very sorry to say, in a very wrong fashion. I mean to say, you are directly given the definitions, you're directly given the proofs, and you really jump into the mathematics and you feel all the problems, frustrations, mistakes, etc. So if you have watched my last year's video on real analysis, I think one year back or so something, I have given a very detailed idea on the prerequisite, how do you learn, what real analysis does, in a very lengthy way in 2 long videos. But as you understand, I am also growing, I am also learning a lot, and my effort has been to illuminate you, to enlighten you more with such easy, I would say, tricks, tips and techniques, so that the life on the mathematical journey becomes easy. So in this video, what I am going to do is going to give you an insight and generate a kind of a motivation and know the real reason in learning real analysis. The problem is that we really do not know real analysis and we jump into mathematics. Remember, real analysis is the tool which we human beings should be happy enough that it gives the privilege to watch the birth of new things, birth of calculus, birth of product rule, birth of limit and functions, birth of convergence and divergence. Think yourself that you are such a human being traveled back in time that you can see the point of singularity when the entire universe is being born. The Big Bang happened and the universe is born. Think yourself standing at that point. Now, we all know that it is not humanly possible, it is not currently possible, but here is a tool, real analysis, which gives you such an immense power that you can watch the birth of new components in mathematics, and isn't it great? So please do not skip this video, because I am going to make the video in small parts so that you can understand the real motto, real advantage and the real reality of real analysis. First thing which I would say you need to understand while doing real analysis is something which is an actual, it gives you an actual creativity in terms of mathematics. Now what do I mean by that? Now for example, if you take an artist drawing the scenery of a beautiful flower or a woman sitting down a garden, or the beautiful waves which are crushing down the seashore, etc., you will see that you cannot really define anything. I mean to say, can you really say that this is the sea and you define things properly, or what is the beauty of the rose, or what is that woman who has got flowing hairs and sitting down a garden? So I mean to say, you really cannot tell anything because those are abstract things. But think of an artist who is giving birth to his or her creation. So for example, if I am singing something, I am giving birth to a beautiful tune. If I am drawing something, I am giving birth to a beautiful picture. If I am writing something, I am giving birth to what you call a beautiful literature. And if I am dancing a classical dance, that means what I am doing is that I am giving an abstractness a beautiful figure. Now, real analysis actually does the same thing. First, what I would like to speak is that the calculus that we learn in our school days, especially the ways, the mathematical methods, those equations, especially the formula, we just plug and play, right? The product rule, the chain rule, the limit, the continuity, convergence, divergence, everything we just plug and play. Why we do plug and play? Because we are supposed to do that, otherwise we won't secure a mark or we won't get a good result in the examination, right? Now the question is that where from these things come? Okay, now as you see that with the progress of human civilization and the progress of science, we are always trying to find the for example, the origin of the universe, where from the origin began, where from the Big Bang, and even up prior to Big Bang things began. So what we are doing, we are tracing back. Remember, we are tracing back to time. So right now, say for example, the universe is in a state when we go billions, million years back, and we are trying to find out the origin. Now, as we are tracing back and we are trying to find the origin, real analysis does the same thing. For example, limit and functions, continuity, divergence, we know those things, right? We are using those functions in mathematics. But the question is that let us trace back just like Big Bang and get into a singularity where you can find the origin of what you call limit, continuity and function. So first you need to understand that it is a beautiful, super beautiful subject which is giving you, I mean to say, we are all fortunate in today's world that we are getting a kind of a mathematics, we are getting a kind of a subject where we are going back and we are tracing back the origin and finding out the subject. This is point number one, that we should consider ourselves fortunate enough, happy, and should be elated that we have got a subject which is finding out the origin of the mathematics that we used to do. The second point which I would like to say is a little bit serious. Now, I really don't know which level of mathematics or which level of, I would say, mathematical maturity you have in order to go ahead with real analysis. But when I faced real analysis, especially, I was not aware about what you call the logical quantifiers. Okay, now what do I mean by logical quantifiers? What I'm trying to make a point is that you should be aware, I would say at least to an expert level, or even not that expert level, up to an intermediate level onto set theory. Because those logical quantifiers and the basic proof that this is so, convergence, etc. comes from using the signs and conventions and notations of logic. I'm not saying that you master the Copy's 9 rules, etc. and go deep into logic and then into philosophy, but at least what you can do is that get aware, know a little bit more about the logical signs, the quantifiers, the universal quantifiers, the and or not, etc. and most importantly, do a little bit of simple proofs on those logical quantifiers. See, the reason is that as you go ahead in real analysis, you will see that the proofs I would say, when we come to the proof theorem, it actually uses a lot of logical quantifiers. Now, we know the calculus, we know integration, we know all those notations. I'm talking of notations. See, what happens is that suddenly an unknown notation, when it comes in front of you, you say, oh, I really don't know, what are those signs about? So again, you have to go back, trace back and find out the meaning of the logics, and then you have to go. So most of this is when you're taking up a first sem of real analysis, by that time you should be aware about what is called the logical quantifiers. Not only that, I would really recommend you to undergo some of the simple logic-based proofs for the for the logical part. So when you face those quantifiers into the mathematics of real analysis, you won't face a problem. The second thing, I would say the next most important thing which comes is that real analysis is what? It is all about proof. Now, you will see what is most important is that why do we need the proof? Now, say for example, in this video I am telling that my name is Shaunak. So I mean to say, why do I need to prove myself Shaunak? Everybody knows my driving license, my parents' name, my neighbors, everybody know that my name is Shaunak. and I do study this. Now, what is the proof? The thing is that I would really recommend you to once go through this one, which is called Principia Mathematica. At least don't go through Principia Mathematica, but try to understand why Principia Mathematica was written by Bertrand Russell and Jane Whitehead. Now the thing is that what happened during that time, I'm coming to the great person Kurt Gödel to that. So during that time, the mathematicians realized that no, even 1 plus 1 equals to 2, even a number minus that number gives 0, we need to prove it logically. That is called axiomatization of mathematical proofs. What do I mean by that? Each and everything that we plug and play in mathematics, starting from class 1, class 2 up to master's level, all of this Bertrand Russell and the other logical people thought that okay, let us make it in a proof-based system so that logically at some point of time it is being proved. So what I need to do, I need to say in this room there are two more people, maybe this Mr. X and Mr. Y, and it shows from their voter ID card that they are not, and in this particular locality we don't have any other people by the name Shaunak, and Shaunak's voter ID or driving license or the SS card shows that he is Shaunak, hence it is proved that he is Shaunak. I mean to say this is utterly a foolish kind of a proof system which is given. All bachelors are unmarried. You need to prove that why bachelors are unmarried. Some kind of a proposition, funny propositions like that. Now Bertrand Russell eventually in that huge work of his and Whitehead proved everything in mathematics through logic. Through logical quantifiers, signs, etc. Everything from pin to elephant, everything was proved by logic. Now why it is being proved? Because we need to see, because my name is Shaunak is not always correct. There can be other people by the name of Shaunak who would be speaking about physics or mathematics, but somehow I have to prove that my name is Shaunak. I hope you are getting my point. So the thing is that mathematical axioms, mathematical definitions are now reduced to real proofs, so that there is no denial. I mean to say there is no other way which says that 1 plus 1 will be equal to 3 or some other number. So commutativity, associativity, everything was strictly proven, and during that time a young handsome man by the name of Kurt Gödel, who achieved his PhD at the very young age of only 21 years, proved that Principia Mathematica is wrong. Principia Mathematica has got logical inconsistency. Anyway, that demands a separate video, and I talk a lot of Kurt Gödel because he is one of my favorite in the history of science. So when we are going into real analysis, what is happening? We are requiring a real proof. So now you will say that why this proof? The reason is this. Without a proof, how will you prove that 1 plus 1 equals to 2 or a series is converging, etc.? So the problem with the students come, oh my goodness, this is proof, how am I going to prove that? So once you understand that why real analysis really requires a proof, then you will come out of that fear. Because without the proof, you know, everything becomes very illogical, everything becomes very light. So you see David Hilbert's that famous book called Grundlagen der Geometrie, that is, I think it is Foundations of Geometry, right? So what he did is that he tried to give some great proof, solid proof on the axioms or the propositions of geometry. So let us remember that we don't have to fear about proofs. Proofs will be there. Without proof, the entire edifice of mathematics collapses. So proof is something which is really required. You can avoid real analysis today by avoiding the proof-based mathematical system, but I can tell you that you will encounter proof one day or the other. So please go through that proofs. How it will go, I am just coming up in the next part of my video. Now, I was just talking about proofs. Now, another important thing which comes across is definition. Remember, I haven't spoke about those things too much in my last year's video, real analysis. I told you that human being matures, they start knowing more, and with my age also growing up each year, I am also learning a lot of new things. And the idea of physics for students is to give you or throw you some light so that your life becomes easy. That's my objective. Anyway, so coming to what are called definitions. Now, what are definitions? We are defining something. It can be a mathematical definition, it can be a logical definition anyway. But what I would request you really is that go through the definitions properly. Now, it is a kind of a house of cards. Each one is dependent on other, and if you do not read one, another will surely collapse. So if you are avoiding logical quantifiers, you won't be able to understand proofs. If you are avoiding proofs, you won't be able to understand definitions. Right? So please go ahead with the definitions, learn them properly, and I can tell you, proving something is not at all difficult. It requires a kind of a I won't say intuition. What I can say, it requires a kind of a very tricky kind of a mind in order to prove something. So this is not, and it is defined so this is equal to this, right? Now, why if it is cloudy, it would rain? But is it true every time it is cloudy, is it raining? No. So how will you prove that whenever a cloudy internet world, what happens is that we just read through that. Okay, we have understood definition. We've just went through that blog. Somebody questioned me when I came in YouTube live that, sir, which is important, books or videos? I told that books are important, and I also requested, but that doesn't mean that you won't watch my videos, right? So anyway, when you are going through each and every definition, write the definitions on a piece of paper. Because what is happening, reading is something, when you write something, things becomes much stronger. Things become much more, I would say, it gets ingrained in your brain much faster. So you wrote down the definition, you know the logical quantifiers, you know how to do a proof. Now you start the proving the definitions one by one. So once you start, don't worry, I will make a separate video on what are the books of real analysis you will get. But unfortunately in India and abroad also, I find most of the students, they find real analysis to be a very raw, boring subject. They try to avoid. But I mean to say, I made a video yesterday on the Golden Beach in Odisha, when I saw that you see the waves coming and crashing, right? Now, isn't it so beautiful to see the waves? Isn't it so beautiful to see the crimson color of the sky? It is the creation by God. It is the creation by that. Let us start from the back, that what real analysis will give. You think yourself that you are giving birth to a product rule, maybe a chain rule, or maybe something else in calculus, or something else in the number system. I'm going to say this is tremendous. This is something great, that you as an individual do have the capacity to give birth to something. Now, how do you do that? Through real analysis. How do you understand that? Through real analysis. What is the tool for developing those wonderful creatures of the earth? Real analysis. Once you understand that what real analysis is made for, once you understand the basic reason, you won't find the subject difficult. You would love to work with real analysis. That is basically the entire idea of today's video. Not to teach you the proofs. For that I am making a separate list on real analysis, don't worry. But in order to generate that interest, to motivate you really that these are the proofs, this is how you do. Most of the time you will see the students or we individuals do not love something because we really do not know the objective. We really lack that understanding that if I am given a wand stick, or what you call a stick which creates wonder, a magical stick like Harry Potter, then you will want that stick of Harry Potter, isn't it? Real analysis gives that magical stick in order to create new things of mathematics. Okay, so that's all for today's video. I don't want to take it much more longer because the idea of this video is to give you an I would say a motto, an objective, and motivate you to do much more in real analysis than others. As I told you that real analysis, I'm sorry to tell, with all my due respect to my great professors and lecturers who are watching this video across the world, Real analysis is taught in a very wrong way. You are just given the proofs, you are just given the definitions and jump with the mathematics. I would say go it in this way. First understand what beauty real analysis would generate, what beauty it would create, and then once you enjoy that beauty, you will find that there is no other subject in mathematics perhaps so interesting than real analysis. Why? Because real analysis actually gives you the privilege, the honor to watch the birth of certain important mathematical axioms, features, components. I mean to say some sort of motivation, some sort of liking for this subject. Let me know further in the comment section. I will be back with more videos. So Shaunak signing off from Physics for Students, wishing you all a good health and may the good Lord be with you. Thank you very much.
Thank you for watching this video. We appreciate your time and patience. If you want to connect with us and provide further feedback, comment or suggestions, please email us at contact.physicsforstudents@gmail.com. You can also follow us on Facebook, Instagram and LinkedIn. See you soon in the next video.